Welcome back to Dr. Potter. In this episode, I wanted to talk about the magic of ceramics, or what happens inside the kiln. The chemistry is really pretty amazing. And if you think about it, if our ancestors hadn't noticed that clay left out in the sun or heated became hard, we'd probably still be eating out of our hands. Now, clay is a mixture of mud and water, and lots of impurities are present. The first thing that has to happen is we have to dehydrate or get the water out of the clay. Even bone-dry clay still has water trapped between the molecules in the clay body. With slow heating, water evaporates out of the clay. But if heated too quickly, water can turn to steam, which explodes the clay in something called spallation. Think of an exploding pressure cooker or something like that. Make sure that you dry your piece as much as possible, because by degrees where water boils, all the water needs to be out of the piece. Clay will then compact and shrink according to its composition. Some clays compact and shrink more than others. The next thing that has to happen is impurities need to be taken out. Clay has a number of impurities. All clay contains carbon, sulfur, and other organic impurities. Dirt, rocks, all kinds of things, even straw. These burn off between 572 degrees Fahrenheit and 1470 degrees Fahrenheit. If this burn is truncated for some reason, maybe due to poor ventilation, carbon coring can occur in your piece, and this can weaken the clay body and leave divots and marks in it. Next, something called molecular water burnout has to happen. This is not the same thing as getting water out from around the clay. Clay averages 14% molecular water. This is water in the clay, not just around it. It's chemically bound to the elements in the clay. As the heat loosens the carbon and sulfur, somewhere between 660 and 1470 degrees Fahrenheit, the molecular water is removed. A slow control firing allows these processes to take place without damage to the forming ceramic piece. And then the magic really begins to occur. Quartz inversions begin to start. One molecule of alumina plus 2 molecules of silica bonded with 2 molecules of water is something called clay. But it's also something called quartz. Silica oxide clay is another name for quartz. Quartz is a crystal that changes shape at specific temperatures. These changes are known as inversions. One such inversion occurs at 1060 degrees Fahrenheit. At this point, your piece can increase and then decrease 2%, and it's quite fragile during this process. Then something called sintering, S-I-N-T-E-R-I-N-G, occurs. Around 1650 degrees Fahrenheit, the clay particles actually begin to fuse. This is what sintering is. This is when clay begins to become a ceramic material and is no longer just dirt and mud. Bisqueware has been sintered but is still porous and not yet vitrified or fully turned to glass. This is why glazes can be applied to pottery without damaging the structure. As the glazes are applied, the pottery changes personality and becomes a piece of art. The glaze fills the porous spaces, making it attractive and beautiful to use and see. Finally, you have vitrification and maturity of the ceramic piece. A maturing clay is a balance between turning the clay to glass, producing hardness and durability, and over-vitrification, where the object begins to slump, warp, deform, or melt. This is a gradual process where you dissolve the original form and make it into something new. Reorganization of the structure and a filling in of the spaces between the particles to make something new. Mullite, which is aluminum silica, develops, and these are long needle-like crystals that arrange themselves to look more like ice cubes, but they don't melt. Maturation depends on temperature. Clays mature at different temperatures depending on their composition. Lower temperatures may produce a soft, open piece, whereas the same piece of clay heated to a higher temperature might produce a hard, impervious piece. And some clays cannot be fired at a high temperature because they will simply slump and melt. Finally, something called cristobalite forms. This is something that occurs as the clay cools. As the piece cools past 420 degrees, a mineral polymorph, which is basically just a different shape of silica, is formed. Slow cooling around 420 degrees is critical so that cracks don't occur as the molecules rearrange and settle. Temperature and speed make all the difference. So there you have it. It's a pretty amazing process. So you don't need to know how this all works to appreciate the beauty of clay, but it does help to understand what goes on in the kiln, where potential problems might occur, and also where the clay is most fragile. I hope you enjoyed this. If you like what you see, click like and subscribe and I'll make some more. Thanks for watching.